Let's start with the question. Shrinking array. Let's call an array B beautiful if it contains at least two elements and there exists a position I such that bi minus bi plus 1 is less than equal to 1. So the consecutive elements must have the difference 1 and there must be at least one position present. So that array is going to be beautiful. Okay, so you are given an array and as long as it contains at least two elements, you can perform the following operations. So we can perform this operation where we choose two adjacent positions I and I plus 1 in the array. We choose an integer x such that minimum of ai and ai plus 1 is less than equal to x is less than equal to maximum of ai and i plus 1. Remove the numbers ai and i plus 1 from the array and insert number x in their place. Obviously the size of the array will decrease by 1. So we have to calculate the minimum number of operations required to make the array beautiful or report that it is impossible. So let's see this problem. This problem has a very good solution. Right, let's see. It has a very easy solution, just observing all the test cases. Okay, so let's see the first test case. So in this question, basically what we have to do is we have an array A and that array contains some elements. Okay, so we can make these operations. This is only one operation which has 3 steps, so we can choose 2 places. For example, let's see the first test case 1 3 3 7. So we can choose 2 positions, 2 adjacent positions. Okay, and we have to choose an integer x such that x for these two, x is greater than or equal to 1 and less than equal to 3. Okay, for this case it's maximum of the adjacent elements and it's the minimum of the adjacent elements. Okay, and we can remove any of these numbers so that we get at least one case in which the difference between the adjacent elements is less than or equal to 1. Okay, so if we see in this case already has this thing satisfied because the position 1 and the position 2 already have those elements whose difference is less than or equal to 1. Okay, so their difference is 0, so it already exists. So let's take this element as 5. Okay, now it's not the case. Okay, so we have to choose x which is present between 1 and 3. So if we compare this position with these 2 adjacent elements, if we take these 2 as the adjacent elements, then there cannot be any value of x present that will satisfy this condition, right? Because x has to be between 1 and 3. So we can conclude that this element which we are on must lie in this range. Okay, so a of I, if this is I, must be less than equal to the maximum of the 2 elements and greater than equal to minimum of the 2 elements. If that is the case, then the operation is made. Okay, right? Okay, so how are we going to proceed with this question? So first thing we have to remember that this range can tell us if the operation can be successful or not. Okay, Okay, so for the first test case, we have 1, 3, 3 and 7. So first thing we have to check is if the adjacent elements are already beautiful or not. The array is already beautiful or not. Okay, so we are going to check all the elements, adjacent elements, and if it is present, we are going to output 0. Okay, because no operation is needed, so the minimum number of operation is going to be 0. Okay, now if we see the other test case, we have 6 and 9 here. So we see the adjacent elements and the difference is not less than or equal to 1. As the difference is not less than or equal to 1, then we are going to output -1. Okay, now if it had happened that the array was 6 and 7, then it would have been an array and a beautiful array, and the output would have been 0. So in this case it is -1, in this case it's 0. Now let's see another test case, and when we see this test case, it's 3, 1, 3 and 7. Okay, so first we will check if the elements, if the array is already beautiful or not. So 3 minus 1, it's 2, so it's not. 1 minus 3, absolute difference of 1 minus 3 is 2, so it's also not. And 7 minus 3 is 4, so it is not already a beautiful array. So how can we check it? Okay, 3, 1, 3 and 7. So if we take this range, okay, so 3 must lie between 3, the maximum of these two adjacent elements, and the minimum of these two adjacent elements, 1. So as 3 satisfies this position, that means we can change these two to 3. The optimal thing is to choose 3 because the difference would be 0, right? So in one operation we made the array beautiful. Okay, now see another test case, 1, 3, 5 and 2. 1, 3, 5 and 2. Okay, so when we compare these elements, we see that it's 1 and 3. So the next element must lie between 3 and 1. So 5 does not satisfy this condition. Okay, so let's check these two elements. So does 2 lie between 3 and 5? No, 2 also doesn't lie between 3 and 5. But let's see, does 3 lie between 2 and 5? It's 5 and 2 here, and yes, 3 is greater than equal to 2 and less than equal to 5. Okay, so what are we observing here in both of these arrays? 3, 1, 3, 7. 3, 1, 3, 7. Here, if we see this element is the least element from its adjacent elements. Okay, right? So one operation was possible here. Okay, and if we see in this array, 1, 3, 5 and 2. This element is the peak element, right? So what are we seeing, that if peak element exists in the array or a valley element exists in the array, then in one operation we can make the array beautiful. Okay, now let's see a case when there is no peak or valley element in an array, because that test case is not given. Let's see. So 1, 4, 6 and 8. Okay, so is there any peak or valley element? No, the array is increasing. Okay, so let's check all the elements. If we check these two elements, so the range is between 1 and 4. 6 does not lie between 1 and 4, right? Let's check the 4 and 6. So the range here is 4 and 6. 8 does not lie between 4 and 6, so this is also not possible. If we see 6 and 8 range, 4 does not lie between 6 and 8, so the operation is not possible, right? And vice versa, if we see 6 and 4, 1 does not lie between 6 and 4, so the operation is not possible. So in this array the output is going to be -1, because no possible number of operations can make this array as a beautiful array. Same for the array that has decreasing order: 8, 6, 4 and 1. If we see this test case, we are seeing that the array is decreasing, right? And if we check if 4 lies between 6 and 8, no, it doesn't lie between 6 and 8. If 1 lies between 6 and 4, no, 1 does not lie between 6 and 4. Does 6 lie between 4 and 1? No, 6 does not lie between 4 and 1. So the output of this array is also going to be -1. So we have made these observations from all these test cases. So if an array is not sorted, then it can be made a beautiful array. How? By only one operation. Only one operation is needed, right? But it can also happen that an array is sorted, like it's 1, 2, 3 and 4, and the operations are 0. So we are going to check that earlier, right? We have to check if adjacent elements satisfy the condition of beautiful array or not. Okay, so that is going to be checked. But if the array is sorted in increasing or either decreasing order, so making a beautiful array will not be possible. So I hope you understood from all these test cases what are we going to do. Okay, so let's write it down. So first, check if array is already beautiful. Okay, other thing, second test thing, if array is sorted. increasing or decreasing, doesn't matter. Output -1, else output 1. Okay, so these three things we have to take care. Now let's see the code for this question. So t is the number of test cases, we input test cases, and for t times we call the solve function. So in the solve function we have n, we see in n, where n is the length of the array. Okay, and I've created here f, bool f is equals to false. So we enter the array, and if I is greater than 0, we check if the adjacent element have difference, absolute difference less than equal to 1 or not. Okay, so here we are checking the first condition, that if array is already beautiful. Okay, if it is already beautiful, we make f as true. Okay, so if f is true, we see out 0 and we return. Else, if n is less than equal to 2, then we output -1. Okay, because if the length is 2 and for suppose it's 1 and 2, so f would be true here and output would be 0 and it would return. But if f is 6 and 9 for suppose, and so f is not going to be true, right, and hence it will output -1 because no amount of operations can make this array beautiful. So we are going to return it, right? And if both of these cases are not there, then we'll check if the array is sorted either in increasing order or in decreasing order. So if it is, then we see out -1, because if it is sorted, then no number of operations would make the array beautiful, else we see out 1. Okay, so I hope you understood the solution and you like the solution to this problem. And if you have any doubts, you can ask in the comment section. Thank you so much.